this curvature will be different. Okay, there's a question given. Okay, let me get into the actually it what question the diagram given, it's right. In fact it will appear like this practically if you see this one. No, some rough diagram I have put it. So we'll do one thing, we'll give names for this A, B, C and D. How the force due to the pressure here will be P naught here A. Inside the pressure will be some other thing. So here pressure is how much P naught. Inside pressure will be P. Concave side, on concave side it will be P. How the force due to surface tension, it should act everywhere tangentially. Am I right? So here it is like this. Huh? On this side also you can show it, other thing. No, let me take this will subtend an angle theta 1 and let this subtend angle theta 2. Let the radii of this surface be R1 and R2. What you should call R2? So it is like this. Huh? I'm giving a lot of supporting diagrams. Please try to follow it. And this will be theta 1 by 2. Theta 1 by 2. There's a radius. Now, arc length, what is arc length AB? Shall we write R1 theta 1? Arc length AB should be R1 theta 1, the first thing. Arc length AB equal to R1 theta 1. Arc length BC is equal to R2 theta 2. What is the, how the pressure on concave side will be more than convex side, everyone knows. So therefore how the pressure force will act? The pressure force will act, the net pressure force will act in this direction. So what is that FP? We can write it as FP should be equal to, pressure force should be equal to excess pressure delta P into area. What is area? R1 theta 1, R2 theta 2, or right, let me write delta A. What is delta A? This everything is delta A. Area of the strip, curved strip. So this is what? Curved strip, not arc. I think all of you know patch. If I call patch, you should be able to understand. Now the delta P, keep as it is. What is area? R1 theta 1, R2 theta 2. Now, who will balance this pressure force? This pressure force should be balanced by somebody, you know. That should be balanced by force due to surface tension. Net force due to surface tension in what direction? Should act downward. Net force. So can you show force due to surface tension? Yes, it is. You can see component of this force along y-axis. Component of this force along y-axis. So where do it will act? It will act here and also at this point. I'm unable to show it. So here as well as this particular here it will be acting. So the resultant of the vertical force, that is similarly here, the component of surface tension acting along y-axis in the side BC as well as DA. It's their vertical components. What happened will balance this one. So shall I say that the force due to surface not acting only at these edges will also acting here, and I'm unable to show it. I can show only at two faces because a 3D diagram. So this I'll what I do is the surface AB I'll show like this. Plane diagram I'm converting. Okay, clear this one. So how much force due to surface tension? Here should act like this here. So how much it should be? Surface tension into length. Surface tension into length. So here it should be, shall we show it on the face AB, R1 theta 1 into surface tension T. Similarly here, R1 theta 1 into T. What is this R1 theta 1 T? R1 theta 1 T is this arc length into surface tension. How do you act? It will not act horizontally. It will be curved, no? It will making some angle with the horizontal. So what is this angle? This angle will be theta 1 by 2. This angle will be theta 1 by 2. Similarly, for the side BC, will take for the edge BC. For the edge BC, again the similar condition. Say now what I am drawing diagram, they are the plane diagrams, huh, to make you understand. The resultant force, we are showing it like this. Comfort. So this should be the BC. No. What should be the, what is the surface tension here? T. What is the length? R2 theta 2. So therefore, this should be R2 theta 2 into T. R2 theta 2 T. Okay, from where this, what is this R1 T1? Where it is? You should really ask me questions, sir. What is this AB you're showing? It should be AB, or you should write this one. And nobody is responding. It seems nobody is understanding. Is it correct? Fine. So if you if you stand here, you see force. This force is acting on the AB. R1 theta 1 T, and on the force CD also then same similar. R1 theta 1 into R1 theta 1 is the length of this, and the surface tension will be the force, and it's in equilibrium. So therefore, these two forces should be equal and should subtend same angle with the horizontal. Is it okay? No. Nobody is understanding. If you say yes, I'll proceed further. Okay, still many are. I'll hmm? Okay. So no. What you can write here? Net force due to surface tension. Now, who will balance this pressure force? Force due to surface tension only. So the excess pressure here P will be greater than P naught. So therefore the pressure force will be acting like this. Who should balance the force due to surface tension? So therefore on that particular element, on that particular strip, I had to show like this here. One more diagram. No, how the pressure force will be acting? The pressure force will be acting like this, and the force due to surface tension will be downward. Net force due to surface tension. Okay, how to calculate pressure force? We have calculated. Why this force Fp? Due to pressure difference. Here pressure P, here P naught. And now how to calculate force due to surface? Shall we take component of this? So let's calculate the force due to surface tension. Force due to surface tension. So how much I should write? This should be 2 R1 T1 into T sine theta 1 by 2. Y2. Anybody? Two components. Component of this will get added up. This is the thing. Plus similarly, R2 theta 2. This is a force due to surface tension. Okay, now. So at equilibrium, what happens? These two forces I should equate. Then let me go for solving. This is the at equilibrium. This is very important. Many numericals are related to this. That's why I picked up here. So Fp is equal to Ft net. So delta P R1 R2 theta 1 theta 2. Already we have this. This should be equal to 2 R1 T sine theta 1. We'll write one expression. Theta will be very small. So therefore this and the whole expression will become delta P. Theta will be very small. So therefore this will become 2 R1 theta. Theta 1 by 2. Okay, this 2 will get cancelled out. So R1 theta 1 square T plus R2 theta square T. Anybody? I'm intentionally doing some error so that I wanted you to notice. Anybody wants to answer? I really want you to make observation. Components, yeah, good. Yeah. The components are like what we are calculating, no? You have to make observation. Okay, you do one thing. So we have done so many problems. It's like a two-step, that's all. Don't bother. Two arcs here. Okay, this is very important. This is AB. Okay, for this strip AB, so you take only this particular strip. So if you take like this, if you take like this here, so we are discussing this one. So here what will happen? What is the force that is acting? R1 theta 1. This should be the R2 theta 2. This should be R2 theta 2 because you are going to take this is the arc for this is the arc. Okay, for equilibrium we are equilibrium. Okay, don't bother these force due to surface tension. Here you should take these arrows. So then what happened here? R2 theta 2 will come here. I think here is what we have to do. Able to make it out. I should shall I write this as AB is the force. Yes, it's correct, that one. AB and CD, if you check it, no. because the force acting on the surface AB, that one. So this should be the R2. Able to analyze? Then this should be the theta 1. Okay, don't change that one. It should appear like this. Okay, on the first one, R1 theta 1, this should be sine theta 2. That's all. Now it will be not okay. Visible that theta 2, theta 1, I made changes. So this should become how much it is now. R2 R1 theta 1 R1 theta 1 theta 2 R1 theta 1 T theta 2 R2 theta 2 T theta 1. So this should become how much? 2 R1 theta 1 theta 2. Let me take common. So R1 plus R2. So here theta 1 theta 2 will get eliminated. So delta P R1 R2. So what is delta P is equal to R1 plus R2 T by R1 R2. Now this will be further will make it. So what is this excess pressure now? So this delta P will become. So shall we adjust this in any other form? 1 by R1 plus 1 by R2. Very, very, very important. So what do you mean by delta P? P minus P naught. So pressure on the surface will be like this here. So pressure inside below the surface on the concave side will be more than that one based on this radii. Okay, what is the use of this? So let me take a cylindrical curvature. Till now, when we took spherical, no? If you have a cylindrical one, what do you mean by cylindrical? How do it will be? Yeah, this will be very, very useful for it. There's a long cylindrical structure. Look at the curvature. Shall I say it's a cylindrical one? What is the pressure at this point? And the pressure here will be P naught. So shall we put it like a long cylindrical one? One radii will be R1, the other radii will be R2, R2 will be infinity. Yeah? Almost you can say there's a flat, no? See, earlier the strip was like this. Huh? To be frank, the strip was like this. The same inverted, no? This one. Earlier the strip was like this. Not possible to show. Okay, now what is the radii of this? Will be infinity, no? So only the radii of this will be there. So R2 will become infinity. So for this is what cylindrical meniscus here to call. So what is the excess pressure for cylindrical meniscus? The radius of this will be R. So what is the excess pressure? P minus P naught is equal to only T. R1 will become equal to R, whereas R2 will be infinity. Here R1 is R, R2 is infinity. So this will become cylindrical meniscus. So what is the excess pressure at the cylindrical meniscus will be this much here. Or You can go for tablet. I think capsules, all of you know capsules. How do the capsule will occur? The best example I'll give it. This will be capsule. No? It is having two edges. So this will have radius r. What is the radius of this? Will be infinity. Radius of this will be r, that one. So what is the pressure here? P, this is P naught. So P is equal to P naught P naught plus T 1 by R plus 1 by infinity. So how much it is? P naught plus T by R. We discussed for what? Spherical drop. Here, if the drop is in the form of a capsule, all of you, I think capsule very much cylinder with closed edges here. Then what is the pressure inside that cylinder should be of this particular form. You may get a numerical, that's why I brought.